This particular figure gives us a different view of the process of producing gametes. Now, the name for the production of gametes is called gametogenesis. Again, gametes, genesis meaning to give rise to or give birth to. So male gametogenesis is called spermatogenesis, again, production of sperm. Female gametogenesis is called oogenesis, or the production of ova or eggs. Now, you don't need to worry about these specific names that you see here. The names of the gametes most people are familiar with. That's the sperm from the male and the ovum from the egg. But I just want to tie this figure together with the concept of meiosis. So we start with a diploid cell. That diploid cell replicates its DNA. We have meiosis 1. Meiosis 1 leads to the production of haploid cells, but we said there's too much DNA in those cells. Each chromosome has its own sister chromatid. So we need to separate the sister chromatids, so that's where my equational division, or meiosis 2, comes in. So reductional division takes us from 2n to n, but the problem is the DNA is still duplicated, so we go through an equational division where I go from 1n to 1n cells. These cells will then undergo the process of differentiation to produce the sperm. Now, the males start spermatogenesis when they reach puberty, which is somewhere around 12, 13, 14 years of age. It can be a little bit younger, or it may be a little bit older. But for each cell that starts the process of spermatogenesis, the male derives 4 sperm, or 4 gametes from that. That's in contrast to the female. The female also does meiosis 1, which leads to the production of 2 daughter cells that are haploid. But in the female, one of the products of meiosis hogs the cytoplasm and the organelles. And so the one that receives less cytoplasm is called the polar body. And frequently the polar bodies will degenerate and not divide again, but it is possible during meiosis 2 to have this polar body produce 2 additional polar bodies. Now, the polar bodies are regarded as non-viable products of meiosis in the female, meaning they will not be able to be fertilized and develop into an offspring. If they did become fertilized, there wouldn't be a sufficient amount of cytoplasm to support the fertilized egg or the zygote. So what we have at fertilization is a haploid sperm uniting with a haploid ovum or egg to produce our first zygote or 2n cell. And so if you think about it, this is absolutely amazing. You start as a single haploid cell, and over the course of gestation, 9 months in humans, that one cell will divide to produce hundreds of trillions of cells. Those different hundreds of trillions of cells will organize themselves into tissues and organ systems, and those organ systems will work in an integrated manner to maintain homeostasis. And that's just an absolutely amazing process.